feel the coal coming off through that glove.
Watch this.
Hey guys, today we're going to talk about states of matter, specifically the changing states of matter. Now, we're going to focus on the main 3 states of matter. I know, there's more than that. Okay, but let's keep it simple today, mostly because anything above a gas is mostly trying to kill you or cost millions of dollars to make. So we'll stay away from that for this video. Solid, liquid, and gas. Pretty much anything you're drinking has water in it. My sweet tea has mostly water. I have some solid water here in the ice, and if I let it sit out long enough, the water in this tea would evaporate into the air, and I would have water vapor. Now, what we have here, this is not exactly what I described right here. Okay, we do have solid, liquid, and gas happening here. Okay, now you can see the gas rising. Okay, and there is water in here. I'm going to see if I can grab this solid. There we go. Solid. Now this is not ice. This is dry ice. And the reason we say that is because this is melting, but it's actually not. It looks like it is. Okay, this is actually sublimating. Okay, sublimation occurs when you have something go from a solid directly to a gas. You'll notice there's nothing dripping off of this, but you can see that gas coming off and going directly into the air. Now, why is it doing that, and why is it not melting? Something seems wrong here. It's because dry ice is not normal ice. Dry ice is made of solid CO2. That's carbon dioxide. Carbon dioxide is what we're breathing out. Okay, we breathe in oxygen. Out comes carbon dioxide. Well, that's just it in solid form. Now, why do we not see carbon dioxide in our normal world very often? You just saw it here. The reason is it has to be extremely cold in order to exist in solid form. Much colder than you would normally experience here in Texas or pretty much anywhere else in the world. Okay, solid CO2, solid carbon dioxide, is negative 109.3 degrees Fahrenheit, negative 78.5 degrees Celsius. Very, very cold. Put that in perspective. The coldest recorded temperature on the Earth ever was in 1983 in Antarctica. And that was negative 128.6 degrees Fahrenheit, negative 89.2 degrees Celsius. What you need to know is very, very close to the temperature of what you just saw me pick up out of this bowl here. So in order for this to occur naturally, it has to basically be almost a world record freezing temperature. So your challenge this week is to show me evidence of something changing its state of matter. Solid to liquid, liquid to gas, gas to liquid, liquid to solid. Okay, a couple things. Make sure you tell me the name of the process. What is the name of it changing from those states? Okay. Tell me what's happening to the particles. When we get specific, tell me about the speed of the particles. What's happening to them? Do they have more energy? Do they have less energy? And I want you to describe the physical characteristics. What do you notice is different now that it has changed from one to another state of matter? And one of the things that happens when you go from a solid to liquid, but especially a liquid to a gas, is that they expand. The reason that happens is they have a lot more energy than they had before. In order to go from a solid to a liquid, you have to add energy, typically in the form of thermal energy. And to go from a liquid to a gas, you need to go add even more thermal energy. And by that time, the particles tend to take on characteristics and have abilities that they didn't have before. They're kind of supercharged. So we're going to see evidence of that right here. I have some dry ice right here in this plate that I crushed up. I'm going to put some warm water in here. And I'm going to put a few of these pieces of dry ice in here, and we're going to see that expansion. You see that this is not very much dry ice. It's not even filling this plate, but you'll see it expand to a very, very large volume very, very rapidly. Alright, so now we got quite a bit in there. I'm going to put this balloon on the top to try to capture some of this. I want you to make a hypothesis for what you think is going to happen. So, expanded, and you see that balloon got much bigger than those little bitty pieces of dry ice that weren't even the size of this plate. I didn't even use all of it. So when we go from a lower state of matter, that has less energy, like a solid in this case, to a gas, we're going to have a lot of expansion. sometimes explosively.